Okay. Oh, I can hear myself. Perfect. So welcome to this Fireside chat with Kelsey. It's really awesome that we got all of this together in 2 weeks. So I'm really glad you're all here. Let's get started. So Cloud Native Copenhagen is part of this awesome organization called the Cloud Native Nordics, and we are all in part of CNCF. As you can see, we have quite a few locations in the Nordics now. We also have some very nice organizers working in all of these different groups and chapters. This is us. There's a new one here. Welcome. And Hans and I has been doing this for a few years now. Of course, Corona kind of put a stop to everything, but we are back. It's awesome. The agenda, we're starting now. That's nice. And then Hans, Rasmus, and Kelsey will do a kind of moderated panel discussion. Then we'll have a break with some food. I know that the work experience team put up some food out here. It's all sponsored by Google, and Google also brought beverages. It's perfect. They brought a lot of beer in carts. And of course, thank you to our sponsors. Now, you can probably see that I have a Unity t-shirt on, and Hans does too. This was done in a very short notice, and this office was close by and available, so we took it. So thank you to Google for sponsoring the food, sponsoring Kelsey's time here, and thank you to Unity for letting us be right here. So if you want to join our community, you can follow us on Cloud Native Nordics and Twitter. We also have a YouTube channel where we upload all of the talks from the Nordics. So if you don't want to travel to Iceland or Finland, you can also watch them there. We also have a website. It's very bare bone, but it's right there. And if you want to help out, you can always just reach out to Hans, me, or Jinghon. Is that correct? Yes. If you want to propose a talk or host an event or just sponsor food and beverages. And also Leo, did he arrive yet? You're right there. I promised to just drop the mic for 1 minute, just so you can talk about the stuff that you're doing for CNCF. Do you want like a minute now or? Okay. Yeah, it's spontaneous. But basically, yeah. Leo, he reached out and asked if we could show this survey, or rather get you all to participate in it. So just a few words if you want to.
Awesome. Yeah, hello. Wow, okay. So we founded a new group under CNCF, Tech Environmental Sustainability, and we just are starting out, and we created a survey to get some general feedback because the entire space around sustainability is pretty new, not much knowledge in the technical space. So we need a little bit of like knowledge or just information where we are standing, so we can just help the community grow and push this in a good direction. So the survey is here. I can also maybe post in Slack somewhere, right? Yes. And we also have a tech environmental sustainability channel. Maybe you're also interested in joining. And yeah, awesome.
Thank you. And of course, I'll also post the slides afterwards, so you can click the link. And now, Unity. So Unity is sponsoring. So I'll just a few words about what Unity is. It's a platform for creating and operating interactive real-time 3D content, games, digital twins, stuff like that. It's really exciting. And we believe that the world is a better place with creators in it. So we basically come to work every day to enable creators to create and be creative. We allow creators to monetize their content. We allow them to host multiplayer servers. We allow them to do everything that you need to do to be creative. So you don't want to handle all of the the nitty-gritty details. You don't want to create an ad network to run advertisements. So we allow you to do that. And we have some crazy numbers. It's 23 billion average monthly impressions, ad impressions. It's crazy numbers. And we also have 5 billion downloads of our apps built with Unity, or apps built with Unity a month. It's really crazy. And right now we have 5,200 employees. We were funded in 2004, and we are in. That's a very old number. Yeah, it's old, but it's also the official one on Wikipedia, which is the truth. We have offices all over the world in 18 countries right now. And of course, we are also looking to hire. So if you want to join the team, go to Unity Jobs on Google. Those guys. Thank you. That's all for me.
Right. So maybe we should introduce ourselves as well. I can go first to continue in the Unity space. My name is Hans. I'm a staff software engineer with Unity, and also a co-organizer of Cloud Native Nordics in the Copenhagen chapter. Unity is a pretty big place. There's a lot of people, and we do very different things. I don't really do anything related to games directly, so I will not be able to answer any of those types of questions. The team I am in is the data platform team. We operate some data pipelines that process a ton of data. So all of these devices out there in the world running Unity, they are sending requests to us, or maybe sending telemetry, analytics data that the game developers can then use to optimize the games or whatever it is. And basically, most of that data that is coming in from end user devices is passing through our system. So really, my job is just to take the data, store it for a short while until it can be processed downstream. So it's a very limited scope of Unity, but I'm sure we'll have some good discussions nonetheless. Unity is a public company now, and there's lots of things I cannot say, and I have no media training, so I'm probably going to say something I shouldn't. So please don't quote me on anything.
But you were being recorded, aren't you?
Yeah, I know we might have to edit a little bit. Let's see how bad it goes. No, I'm sure we'll do fine. But just those caveats are in place.
Twitter's okay.
Yeah. That should be fine. Do you want to go next?
Yes. So my name is Rasmus. I'm from the Google side. I work as what we call a customer engineer. So with customers, but I have a background in software engineering, and I'm I would say, avid Kubernetes enthusiast. I've been with Google for about a year's time, and before that, I was with Microsoft for 4 years. So. And before that, I did startup stuff. So yeah, here to support.
Kelsey Hightower. Hopefully, maybe you know who I am. I've been at Google for 7 years as of yesterday. That was my Google anniversary. What do you get for being there for 7 years? You get more free massage time. I've never gotten a massage at Google in those 7 years. So I don't understand what my balance is. I work on a lot of things, but to surprise of many, Kubernetes is not one of the areas I spend much time on. As of 4 or 5 years ago, I became super interested in other areas because, in my opinion, Kubernetes is a small piece of the puzzle. It's an exciting piece of the puzzle, but it's much smaller than most people realize when you really zoom out and ask yourself, what does it take to actually run software globally around the world? And so for me, working on serverless, or what serverless should be, thinking about data systems and what they should be, thinking about CDNs and what they could be, those are the things that are super interesting to me. I think Kubernetes still remains this nice experimental sandbox for us to develop new workload types. I think the community got really excited about a deployment because of Docker and containers, but that's only one workload type. There's lots of workloads out there. There are bigger workloads out there than even Kubernetes are suitable to run. And so as we experiment in this Kubernetes landscape, the whole CNCF, all these open source projects, people remember this last 10 years and probably the next 10 years to come as this great experimentation phase, and then it will consolidate. All right, maybe Prometheus will be the way we think about observability. Maybe it will be open telemetry. But this phase is, to me, the way I observe it, it's a bunch of experimentation. And as those things get codified, they will now become the foundation for the next thing, right? There will be a whole new movement that will treat this stuff like ping, pipe, and power, right? IP addresses are very boring, but they are the foundation of the internet. You can imagine the first IP address. There was a whole conference for it. I don't think people talk about IP addresses that much anymore. So that's been my view and journey so far since the early days of all of this stuff coming together.
And then I look at the questions I had lined up for you, and it's all about IP addresses and Kubernetes.
And we should talk about them because the way I view these things are very much from this pragmatic viewpoint, right? At some point, you have to realize keeping these things front and center in your organization is probably causing a lot of pain to a lot of people who want higher level abstractions, right? When Kubernetes came, because we wanted better abstraction than just what Docker was bringing to the table. The concept of a pod, the concept of a config map, those were abstractions. So what do you think people want now that Kubernetes has been around for almost a decade? People want higher level of abstraction. So what do you do upon that foundation?
And that's perfect. I have some questions that will maybe go into that a little bit. I think we also have a theme, right, for the first part. We're going to talk a little bit about multi-cloud as well. At least that's my understanding. And there's so many different directions we could take this. One, to start off with, is I would like to get your take on being cloud agnostic. Kubernetes is a great enabler for us to have a common set of APIs that are available in basically any cloud that implements the correct interfaces. So, but there's also other things than Kubernetes. You yourself have often spoke that stateful applications is not necessarily the best fit for Kubernetes, but there are also other things that the cloud provider provides. For instance, here in Unity, we are a very big user of Google BigQuery, and there's a trade-off to be made, I think, between remaining cloud agnostic and then using some of these cloud provided or managed services. So if you want to enable yourself to be multi-cloud, then how should you do that when you also want to capitalize on some of these services? Because BigQuery is a magical thing when you're starting out, right? You just dump all your data into it, load jobs cost nothing, and then you only pay when you query it. But then, of course, at our scale, it's no longer that cheap, for sure.
Good business. We love that you pay your bill on time.
Yeah. And we love the food and drinks and you being here. So the way I see it, and the strategy I have, is that you want to remain as cloud agnostic as possible. And then there are these services like cloud storage, BigQuery, and luckily your competitors like AWS has a similar product. They call it AWS Athena for BigQuery. So as long as you can find a equivalent in all the clouds, then you are in a okay agnostic world.
Yeah, I mean, so let's say you have the Unity game engine. It's beautiful. I saw the stats up there. And for the developers to get the most out of Unity, they cannot be game engine agnostic, right? The value comes from the things you do that other game engines don't. That's just how value works. If Kubernetes was runtime agnostic, then we would all still be trying to figure out how to use Mesos. But we chose to do something very different. Nomad is very different. The good news is that these protocols, if you think about Kubernetes as a protocol, a schema, it is usable across the various cloud providers. But we all know the truth. If you make an ingress object to create a load balancer, what you get in GCP is very different than what you're going to get in AWS. So I think the protocol, and then you have workflows. Most people are after a similar workflow. So when I write code in Golang, I write my code in my IDE. But when I want to run on ARM, the compiler has to do something different and it will produce different instruction sets. If it's going to be Wasm, that is a very different target runtime, and half of my libraries may not even work because Wasm doesn't support that. But my workflow is the same. I write code in my IDE, and the compiler spits things out that will make it work for the target machine. In many ways, Kubernetes is a compute abstraction that attempts to give us the 80% use case, similar workflow, common protocol, but things get very different underneath the covers. And so I think the goal of people who are on platform teams, I know platform is a big topic these days, platform versus DevOps. But when I think about platforms, your job is to make few people have to understand the differences. That's really the end game. Like if you think about electricity, I'm from the US. Every time I come to Europe, I got to bring my adapter. The plug is very different. People who travel a lot, like, oh, I forgot my adapter. USB is very common. So those are common interfaces that you can see globally, but those sockets are slightly different, so you need adapters. And you look at the lower levels of Kubernetes, most of it is just adapters. We call them CRDs or operators. They're just adapters trying to adapt one world between another. And if we do it right, that adapter for Postgres, that adapter for Elasticsearch will give me a protocol that I can understand that sits on top of the cloud provider. So I think, yes, you can attempt to be cloud agnostic. Someone in your organization can be, but there's always going to be a group who will have to understand the cloud really intimately, how IAM works, how billing works. If you forget how billing works, you will be reminded monthly how that works. So I think it's a good pursuit that we have. We're all moving to standard protocols. I'll say one more thing. We have a fantastic kind of multi-region database called Spanner. And when we're collaborating with the Spanner team, what can we do to boost adoption? Of course, we can make Spanner even faster. But the thing we decided to do was to put a Postgres protocol on top. And if you notice, a lot of the new databases these days are multi-protocol. You want to do something that feels like MongoDB, I will give you the MongoDB protocol on top of roughly underneath the hood is a key value store. And so I think that's where the world is going, open protocols, and we might have proprietary implementations based on the performance and SLAs you're looking for.
Absolutely, and there are some abstractions in Kubernetes that have served us really well, like a part, a deployment, a replica set, and these things, and they are function more or less the same in all deployments of Kubernetes. Then we have the ingress object, which you mentioned. This is the odd one out, right? There's so many different ways of getting traffic to your system. Like you could do a service type load balancer, you could do ingress, and then the details. I think it's still a very useful abstraction to have the ingress. I always liked it, even though it got a lot of stuff said about it. But then you basically control all the cloud things through like annotations on the ingress. And I'm not sure what is the right thing going to go forward.
So for those, when we're designing Kubernetes, you have the ingress object, right? Like how to create the baseline for getting traffic from a load balancer into the cluster itself. But then where there are things that are different, you have all these annotations, right? Like you look at these things like, whoa, what are these annotations? Like we make them up, and they are usually specific to an implementation. But I do think the one benefit that Kube brought to the table was at least you can see them. At least they're in at least one place where you say, this is what we expect to happen. And it's not spread out across so many areas and tools. So that is one value. And over time, we turn annotations into specs. So all of those annotations led to version 2 of Ingress, right? That now understands that there's more things you want to do. Routing should be a first-class thing and not left to an annotation. And so it's just this common feedback loop of what I mean by experimentation. We're going to experiment. We'll come up with new ideas. And the last thing I'll say here is, like you mentioned BigQuery, for example, that is a very much a Google-specific thing, the way we do things. And I've often sat down and said, like, why do we even say multi-cloud? How many of you have ever worked inside of a data center or worked at a company that has their own data center? Lots of hands went up. I've never in my whole 20-year career ever thought about the data center as multi-vendor, right? There's a rack, there's a switch made by Juniper or Cisco. You may have storage from NetApp. You may have servers from HP or IBM or Dell, but we never stood in front of the rack and said, oh, we're doing multi-vendor, right? It just doesn't matter. Why didn't we say multi-vendor? The APIs were different to configure them. Some of them had different login semantics. Oracle needs username passwords. Some of them use things like certificates, but we never once said multi-vendor. We just make it work. And I think it's because the network wasn't such a barrier, right? All of these things usually connect through low latency Ethernet right there in the rack. But in cloud, that's not the case. You pick one cloud provider, the biggest bill you will have is the egress or ingress cost to the other cloud provider. So that makes you pause and say, whoa, 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 whoa. You can't just do that. You can't just use S3 and GKE because the bill is going to be crazy. The networking will dominate the cost. And so imagine a world one day in the future where there is no more networking charges. Just imagine that world where it's just
Sounds very nice.
flat world. Will we even say multi-cloud anymore? We probably wouldn't, right? We would just say, I'm using S3 and I'm calling in it from the closest region to that bucket from a different provider. So I think the only reason why we're saying multi-cloud today, honestly, if I had to boil it down to just one thing, it would be the network layer. Even though authorization is different, all of our systems currently, the authorization is different, and we still figure out how to make it work. So if we can remove the network barrier, maybe we don't talk about multi-cloud the same way we do today.
So many different things we could go into on that. I think we maybe want to bring it back a little bit and talk about some of the motivations for multi-cloud, since I want to maybe present a different viewpoint. So I think it's the case for many companies and very much also for Unity that multi-cloud really also becomes a thing because as you are acquiring other companies, they might not be on the same cloud as you. And I think previously you were seeing these big cloud migration projects. Whenever you acquired a different company, you would try to merge the clouds into one, right? But as we grow, you know, that becomes less and less viable of a strategy. And so really it pushes on us to support all the major clouds, at least the most likely clouds where we'll acquire a new company or merge something. I think that's a very, at least one key driver for multi-cloud. I also previously, which is a little bit more field specific, I was a couple of years ago, I was in a Google Cloud Next conference. I sat next to one of the lead engineers on EA DICE. They're doing game hosting, and sometimes, you know, he said that they use all the clouds, and not even just all the public clouds. They also have private data centers because they really need to push the servers as close to the users as possible, because that matters a lot when you're doing multiplayer gaming stuff. So that can also be a motivator. So I think there's really one motivator is that the cloud migrations is painful. And you know, the resources sunk into that maybe doesn't make sense. And other motivators could be something related to either feature sets or just kind of spreading out your workloads and different.
No, I agree 100%. I think at this point, if you buy a business because it's successful, the last thing you want to do is pause all innovation going forward for a cloud migration. Right? I think a lot of people are seeing that. And so yes, that is one of the big ones. The other one I think you also mentioned was, I need to be where my customers are. And cloud providers only have so many regions. There's some overlap. There's some unique spots. But there's situations where, look, if I want to go to a certain region in the world and there's only one cloud provider there, then that may be the one we want to use. And we hope for common protocols. I think the other one we're starting to see is regulation. Right? Some governments are saying, I don't care how good the other providers are. You will use the one that's here. So if you want to do business in this country, the only option you have is the native one. And the other one that I've seen is, let's say you're in the SaaS business, right? You have a software as a service, people come, ideally, they don't care where the data lives or how you run it, as long as you provide a good service. But now there are some enterprises that are so big, like if you do business with, like, I don't know, Walmart, in the contract, they will mention, you must run my backend on this cloud provider, and you must prove that you're doing so. And so I think a lot of SaaS platforms are now being mandated to say, yes, I know you run on, let's say, Azure, but we run on Google, and we prefer all of our data to remain there as well. And then that will become another implementation. So I think we're seeing this from all angles. And honestly, these are pretty pragmatic and good reasons to do this. The old discussions around multi-cloud where you should just do it for resiliency, that one didn't really pan out in my opinion, because that alone you can probably achieve by going for multiple regions. there are really many ways of getting to resiliency, but these other business factors, I think, are the more pragmatic ones we see in real life.
I think you're absolutely correct on that. And another very pragmatic factor, which you did speak a little bit into, is going back to that thing about the network cost of things. Certainly at our scale, but also at smaller scale, it matters a lot. If you're using a SaaS product and you're transferring a non-trivial amount of data, if it's another GCP customer, even though it's not like anything related to you, but if they are also in GCP, you only pay the internal transfer cost. But if they're in a different cloud, then that's a whole different story.
100%.
So looking forward to you changing that.
I think the world will realize there's going to be a lot of value in having the network not be a barrier. Lots of things have gotten much better in society when the communication lines are eased. We see this with mobile. I remember when I got my first mobile phone, to call anywhere outside of your local city costs extra. And now I have a T-Mobile. As soon as I land in Europe, it says, oh, luckily you're on T-Mobile, you're covered. So I think we have to think through that as society. And I think cloud hopefully trends in that direction. And if I have any say, I'll definitely be recommending that to the right people.
I'll maybe like to circle back to some Kubernetes stuff, but let's say you're in a situation where you have to support multiple clouds for some of the good reasons we just talked about. Now, one of the things that a lot of companies are doing today is to also use the Kubernetes resource model to provision cloud resources. Well, they're using like the config connector in GCP. So that's where you declare your application, just make sure everyone is on the same page. You declare your application with a deployment and all the things you normally do in Kubernetes. And then let's say you need a storage bucket, right? A very typical thing for an application to need. So then the config connector from GCP allows you to do like kind Google storage bucket or whatever it is, which then provisions that, which is very nice. But then it's what happens then when you have a AWS application, and then they also have a similar product, Operate or something. But then now you have to version your things. You have to say, okay, but this application is going to be deployed, or this instance of it is going to be deployed in AWS. Therefore, I need to specify my storage bucket in this way, and if it's Google, then this other way. We're losing some of those nice abstractions that we had in Kubernetes. That is overarching. So I don't know if there's any initiatives going on right now that will kind of be a unified way of specifying basic primitives, I would almost call them in Google, like in the cloud, like storage bucket is something that every cloud basically has. I don't know if Crossplane can do anything, but there are some solutions out there. But it's also a matter of like, what abstractions do we need for our applications going forward?
Abstractions really work well when innovation stops. Okay, like when you're done experimenting, when you're done needing more improvements, then you can consolidate, and then the abstraction will arise. IP addresses, we're done. We don't need to make a new type of IP. Some people may want to, but it's so stable, you can just have IP. And there are lots of implementations. There are a lot of optimizations, encapsulation patterns, but IP, that's all you need. And so when containers came out, we still use IP. We implement it really differently. But IP, we're not there yet. I remember when Terraform came out, I used to work at Puppet Labs from around 2011 to 2013. And before working at Puppet Labs, I was using Puppet in a financial institution. Everyone thinks they're abstractions. Most of these things are not abstractions. They're automation, which I think is very different. There's an underlying thing like a server or S3 bucket. And humans have to tell the thing what to do. That's configuration. And so what we're doing is reinventing configuration management for the 5th, 6th time. That's what we're doing. In the Puppet world, we put an agent on the server because it had no real API, not a clean one. And so Puppet gave an API to a server where there was no API before. And then we had the Puppet DSL, so you write Puppet code. And now we had a dialect to tell the machine what to do. And then we get a real new abstraction, Docker. Docker says, forget POSIX for a moment. Let's give a real API to the package build and run process, which is very different than the POSIX interfaces. And so now we get this new abstraction, but guess what? We still have a config management problem. We can teach Puppet, Chef, and Ansible how to create Docker runtimes through the same languages. But now that this is a more declarative environment, Kubernetes came to be config management, if you think about it. If you take the scheduler out, Kubernetes is kind of config management for Docker. What is a pod? A pod says one or more containers on this machine with these volumes, with these environment variables. It is configuration management. That's what it is. The scheduler part is the thing that says, oh, one of the things you want doesn't exist, so I will create it and bind it to the server. But once the scheduler has placed the workload, then the agent, just like the Puppet agent, looks at the manifest and says, oh, this is just configuration. Create a sandbox, Docker create this thing, Docker create this thing, mount these things, almost the same thing we were doing before, but we now have this configuration language. In the middle of that journey, though, we had Terraform. I remember when Terraform came out, we looked at it and said, oh, this doesn't support nodes. This isn't configuration management. Puppet, Chef, and Ansible are all about machines. They have agents and identities, and you give them profiles. The cloud is different. The cloud only has a resource model, and you create objects in a global control plane. And I remember I used to be an early contributor to Terraform. There was only one VM type. Everyone was like, yes, we finally have one VM type. This is going to be awesome. It works for VMware. It works for Google Cloud. It works for Amazon. Life is finished. And then we started adding features. GPUs, multiple volumes, live migration, auto scaling groups. So much that I remember in those days, they said, that's enough. We now need cloud providers. So now Terraform has a bunch of providers that are hyper-specific to that environment, because what you're doing is configuration management. You're not abstracting, actually. Even though we want that, that's not what that is. So when you talk about Kubernetes, why do people want to use Kubernetes for configuration management? We know why they want to use it for managing containers, but why do they want to use it for config management? Number one, Kubernetes is like a big hammer.
Yeah.
And config management looks like a nail, right? So if you look at your Kubernetes cluster, you're like, we can solve config management with this, but we don't explain it that way, so it gets real confusing. We say cloud native something, something, digital transformation, everyone's confused. But the problem is config management. And so why is Kubernetes interesting for this type of workload? Remember that experimentation thing I talked about? We know we want people to declare these things. We know the thing that we're declaring now has a much better spec than servers had. And so, yes, I should be able to tell you, I want an S3 bucket that looks this way. And so Kubernetes says, oh, you can store that declaration with me. And the problem with Terraform is you run it and it does its thing, and then it stops. If someone changes the bucket, Terraform is like, I don't know. You have to run me again, and I may try to fix it. So you have an ownership problem. In the Kubernetes model, Kubernetes says, when you give me this resource, I own it. I will create it, and real time, I will synchronize it. And given that, it's very attractive for this kind of problem. But what we're doing is config management. I don't think we're going to have a situation where we can have one bucket type, because then we're going to look like Ingress again. It's going to be 700 annotations, and someone's going to say, can we just not make another type? Like when we write software, you have a different type. It's okay to have types. So at the end of the day, complexity will boil down to types and automation to realize those types to the thing that owns the resource. I think that's where we're going to end. And the things that do become common, like at Unity, you might say, oh, now that we have the low-level primitives, the types, of course you can create your own bucket type, but don't be surprised if no one else in the world, except for the Unity team, can use that type.
Absolutely. But that's also a little bit the beauty of Kubernetes is that it's been, over the years, it's become more and more extensible, right? You have the operators pattern coming in, and I can create my own CRD and make my bucket type. And yes, maybe it will only be used internally.
You know what's beautiful about Kubernetes? We did the right level of extensions. The API server all it does is store data. It doesn't do anything else, right? It can do some validation. It can do commit hooks that says, hey, let me run another process to make sure that this artifact is valid. But that's all it does. It's a much better etcd with its own API semantics, just like the RESTful API that is used outside of web browsers. But the whole controller thing, you can run controllers wherever you want. You can run controllers on a VM. There is no reason that you have to run the controller inside of Kubernetes. You literally can just run it on a VM. You can run it on your laptop. You can run it in Cloud Run. The only contract between Kubernetes and the controller is this is the place we synchronize data. So if you want to create an S3 bucket, you watch the Kubernetes API, you take the definition, you create the bucket, and you update the status field. Where you do this doesn't matter. And I think that's the part I hope the community starts to understand. This is an implementation detail that you run controllers inside of the same cluster. The last thing I'll say here is the Vault team from HashiCorp, right? They have this Vault controller. And I remember talking about this pattern maybe 4 or 5 years ago in the GitHub repository. But I also said, listen, if you put the controller inside of Kube, that means anyone that can create a CRD in your cluster can ask for secrets. This is dangerous, right? If I just get access to the cluster, I can be like, give me the HR secrets. And the controller will be like, yes, declarative. And it will just pull in the secret. You're like, oh my God, this is silly. But if you reverse the pattern and you got rid of the CRDs altogether, and you just go to Vault and teach it how to talk to Kubernetes, the push model, you can say, hey, Vault, I want you to synchronize this secret into these 1,000 Kubernetes clusters. It will feel the same, right? It's just that the control point changes.
Yeah, and I think that's a good guidance for anyone thinking I want to write an operator, that you should think about it without Kubernetes as well, and it has to make sense. So speaking a little bit more about config management, I know that Ansos is an interesting piece of tech from Google. Originally, I thought of it as the service mesh thing, which is also something we could talk about. But there's actually a new thing called Ansos config management. And one of the components of the Ansos config management system, which I recently learned about, is the policy controller. I know you're a fan of OPA, the Open Policy Agent, and the Gatekeeper implementation. And Ansos for config management does the same thing as it did for the service mesh. It uses these open source components, uses the Gatekeeper, as far as I understand it, but wraps it in some Google specific things, or at least it kind of becomes like a managed service that you then deploy using the normal Google tooling. And I just wonder if we are, in the interest of building an understanding of the components that you run, and also remaining cloud agnostic, if we, or Google is doing the users a little bit of a disservice by providing these packaged solutions that are really the open source solutions. Wouldn't it be better if the users learned how to deploy and use OPA instead of Ansos config management? Because like we are taking these open source components and packaging up, and then you kind of become a little bit disconnected from the original open source project.
Yeah, I'm going to learn how to write a game by generating assembly. You'd be like, there's a game engine.
Okay.
You know the answer. When we think about, so there's a difference between community and customer. Community says, we want access to shape our own future, and open source is one great way of doing it. We can all kind of collaborate. I don't think a lot of people understand in the community what this means. There's maintenance, there's security reviews, there's a lot of work that goes into feature development in the open source world. We have just been lucky that all of that work has been sponsored by a larger group of people. That means probably 99.9% of people just consume open source. Very few people contribute back. That has been the relationship. So of course it feels nice to say, there should be some company writing software for free and make it free forever and support my feature request. That's community. It's a weird relationship, but that's community. Customer says, I am willing to pay for my request. And so our customers talk to us in the context, usually of GCP first, and maybe even another cloud provider like BigQuery. We have BigQuery Omni that moves parts of the BigQuery infrastructure to a different cloud provider so they don't have to pay the data cost. So that's one good way where we get feedback from our customers to do that. But when you talk about config management, I think it's good for a cloud provider. If you can't take care of your own customers on your own platform, you may not be ready to extend to the other side. So config management was kind of built for the paying customer that says, GKE should be easier to use in this way. And so of course that team goes to focus on that paying customer because we don't necessarily have the bandwidth all the time to create industry-wide standards. Because I think the other part of open source is consensus building. You can't just put something out there. You actually have to go and advocate for other people to adopt, including your competitors. This is hard. Consensus building is a thing that takes decades. And so you have to ask yourself a question. Do we create something that just works great for the GCP customer, or do we wait until there's global consensus? And it turns out config management is actually now open source. So adoption is really about who wants to run it and who wants to provide it as a managed service. But I do agree with you that I'm a big believer that we all should understand the fundamentals. This is why Kubernetes the hard way was written, so that everyone understands what's actually happening underneath the hood. And honestly, once there's a big educated group of people, then you can keep the cloud provider honest. You can say, hey, whoa, this thing is moving in a direction that's not just not good for the community, but it's not good engineering design if you back yourself into this corner. So I think that is just the relationship that you kind of see. But I agree, I am a big proponent of open protocols, even if the implementation is proprietary.
Okay.
You have to process that, like you're not sure if you want to accept the answer.
No, I accept the answer. I just trying to figure out which question I should actually.
And look, we're gonna have audience questions. I don't know if we should take some now, but the goal was after we eat to do Ask Me Anything.
It's going to be all.
So my guess is you all came with some good questions, I hope. Yeah, you do. You got a question. He's like, yeah, I got it written down. You ready? Okay, when we get back.
Yeah. And if there's someone with dying to say something,
anyone have a question right now that they want to ask? There's a mic. Don't be shy. All right, you have one. Here's a mic. It's coming. Don't throw it because we don't have insurance if you miss.
I think it's related to the last subject, and I would like to know whether Google or any cloud providers at some point will sell the developer experience. So what I see is that those open source projects, they typically don't focus on this. And then you have this sales demos sometimes, but you come home and things don't work as expected. So do you think we will go in this direction?
And I use this analogy, and if you work at a cloud provider, you can get mad at this analogy. If you're a customer, I think you understand this analogy. Cloud providers have to service lots of people building their own thing. We have customers that are also trying to build their own developer experience. And so the analogy is that the cloud providers are kind of like the grocery store. We have to provide ingredients, not like a farm where you go pick the vegetables. That's too low level. But we do provide things that are ready to go. They have a package, they have a price, and you can take those things and add them to the thing you want. When people say developer experience, in their mind, they think they want to go to a restaurant. Right? I don't want to bake my own cake. This is too complicated, too many choices. There's too many versions of flour. There's too many things that I can put in the cake. Why should the cloud provider just not give me a cake? And you say, but I'm allergic to milk. And this guy says, I don't do eggs. I don't like chocolate. I want all cakes to be vanilla. Anything else is bad. As a cloud provider, you're like, I think we have to sell everything. And there's only so many cakes you can bake. Sometimes you do get it right. BigQuery is very close to the ultimate experience. I dump a bunch of data and I want to run queries on it. Looker is a thing that says, give me dashboards. But how much higher can you go before a person can only do what your thing provides, and then your audience becomes very small and narrow? So I think the progression typically goes, low-level component that anyone can use. And then they will create their own experiences. And then when we see a great pattern, if you think about the transition from Kubernetes to Cloud Run, when you look at Kubernetes and how people use it, mostly people are just deploying one container at a time in the pod. They just want to send traffic to it, and maybe they want to manage traffic between releases. Okay, we can move that experience up a notch, but not too far, because then you're Heroku or Cloud Foundry. And Cloud Foundry, as much as they wanted to be this better developer experience, it didn't scale. Why? Cloud Foundry didn't support the new workload types. People want to do machine learning. People want to do batch jobs. People want to do things that this ultimate abstraction doesn't work, and then it breaks. So the cloud has to be very careful that Kubernetes is just a thing that runs on top of GCE. VMs, auto-scaling groups, mounts, that's what it is. But it has this experience that if you're a platform team, for a platform team, Kubernetes is a great developer experience because of what they want to develop. But if you're a developer writing code, you're like, why am I writing YAML files? Why am I building container images? This is too low level for me. So then we can give them App Engine, where they just push the source code and we do all the things, but you must conform to the App Engine way. There's only 5 golden languages. And if you don't write in one of those, then too bad. You want to do Rust? App Engine is not an option, right? So developer experience, the higher you go, the less developers you can support. So I think we're still in the era where the people who are best equipped to provide developer experience to your unique situation is your developer platform team you have internally. Spotify has Backstage. Backstage came from them looking at the cloud and saying, what's missing? And they built this thing that was great for their development culture and experience. My guess is there's going to be lots of these different ideas. And going back to the other analogy, there are many restaurants, all catering to a certain group of people. They have different types of menus, different prices. And then grocery stores or wholesalers, they provide the ingredients because you don't want to buy all your food from the local grocery store. There's no way they're going to do a good job. Sometimes you need a chef that has their own idea that just won't be scalable for the grocery store format. So I just think that's just the way the world's going to be. And honestly, the reason why we get paid in this room, because if what you thought about existed, you trust me, we will not be hiring all of these people to create these experiences, right? You can just say, e-commerce platform, enter. Whoop, we're in business now. Just load up the catalog. When that world comes, trust me, we will all be doing something very different than what we're doing now. Also, let's talk about Copilot. So we have GKE. It's been a great service for us, right? Like, I honestly think it's one of the best Kubernetes implementations still, right? We're talking about Kubernetes distributions. You click one button, you get the nodes, you get the control plane, you can have multi-zone or regional clusters. We do in-place upgrades. It's a really solid service, but you still have to think about the nodes. And so when you get feedback from people, they said, look, all I really want to do is run this pod or this deployment. Do I really need to think about node pools and sizing and pod disruption budgets? That sounds like a lot. And so GKE Autopilot is actually the same stack as GKE, but it has a default config that is so good that we can remove the nodes. That means our scheduler and the way we think about placement, we have to figure that out in a way that's efficient for us. That way we can have a fair price for you. And so I think GKE Autopilot represents what most platform teams are already doing, right? You don't want your developers thinking about nodes and capacity and all of these things. So Autopilot is just that thing. From experience, we've learned enough that we can hide the nodes. When you think about workloads, Cloud Run says, what happens when you hide the majority of the Kubernetes API and only leave things that are about the application stack? That's the progression.
Speaking of developer experience, there are sometimes, we have these useful abstractions in Kubernetes like a deployment, but then sometimes you have some good practices or something that you want to build in, some piece of boilerplate. I wondered, like, what are some of the things you always go for in deployment? Like, for instance, sometimes you really want to be quite explicit about anti-affinity rules, which is a pretty basic thing, but also a pretty important thing if you have are thinking about highly available applications. So that could be one example of something that is kind of a boilerplate you always add to something, or maybe not always, but then, yeah.
So continuing on the theme of config management, right? Like think about a compiler. It has this high-level programming language. In the Golang, we have built-in concurrency. So when you go and use the web server package for Go, and you say, hey, create an HTTP server, and you make a handler. And when a request comes in, the Go runtime and the library automatically creates Go routines to handle every request. You don't even have to write that code. It's just an implementation detail because we wanted that to be part of the stack. So Go has not only built-in concurrency, because you can make your own channels and fork and handle requests by yourself, but the default library just assumes that's what you want to do. In Kubernetes, again, it's configuration management. So if you step back and you ask the team, how do we want this workload to work? And the team says, well, it should only run on nodes where this other workload runs. Okay, write that down. It always needs 64 gigs of RAM to start, but we're okay with scaling it down in the evening. Okay, write that down. Once you write down all of the configuration requirements, the next step is to articulate that to Kubernetes. How can you articulate it? You can do it by hand. So instead of using Golang, you can write assembly by hand. That sucks, but you can, but you don't. So now we have things like Helm charts. We have things like customize. We have emission controllers where you can just patch in common configuration. I think our goal has always been to the person that wants to run something, how much information do we need from them? If you're writing a programming language, you have your own syntax. And your goal with the syntax is to make it easy to describe computation so that no one has to ever describe things in assembly. And so when you think about config in Kubernetes, to me, I just understand the fundamentals of Kubernetes YAML files are assembly. You can create new instruction sets, CRDs, but at the end of the day, that's low-level assembly code. And then what you give to your developers is up to you. You say, hey, we're going to use templates because we think we can generate all of the boilerplate for the Kubernetes machine. So to me, any of the tools will work, but the best examples I've ever seen, there's a pattern. I just say, whatever your company name is, .yaml. So if I come work at Unity, ideally there's like a Unity deploy .yaml. And you ask only the questions that I need to work at Unity. Hey, we use Prometheus. I don't have to tell you that. Just say my metrics on /metrics. You can also copy and paste some of the Kubernetes spec there, but not all of it. Do you really need to express anti-affinity? Maybe anti-affinity becomes a policy. Any app that is serving games must always have anti-affinity to this. We don't have to write that every time, but you now need another layer. You need that layer that can say, oh, this app meets this profile. We know what that means, and we will just generate the bindings. That's the ultimate pattern. And great CRDs, that's exactly what they do, right? They create a new dialect, you fill that out, and then that dialect serializes to other things, and the status fields allow us to link what's happening so we can debug. That's it. That's the way I think about Kubernetes configuration.
I haven't really thought about maybe making a CRD for something like your application, or because what the pattern I've seen a lot is that some centralized platform team will make the Helm chart to rule all the Helm charts, and then they will kind of only provide you with a certain amount of values you can set, and then they will control the rest. And I think that is a little bit unfortunate sometimes if you have users that actually know assembly, in this case Kubernetes YAML, and want to specify something, then they have to learn the internal equivalent in the Helm chart.
Yeah, Helm is making the same mistakes we made at Puppet Labs. They're making the same mistakes that Chef made. When you make a Chef module, it seems good on the surface until you want to do something the module doesn't do. And now you have to go and change the module with another if statement. The more if statements you have, the more complex it is. That's one way of doing it. And that's the templating pattern, right? Whenever you see low-level assembly, you can implement it by introducing templates. Templates are good if people don't want to change anything. But what happens when they do want to change anything? And this is why I think compilers are such an interesting field. Compilers say, we understand the system calls that can be made to implement these primitives we present to you. And so if you make a Unity-YAML, so there's the operator pattern where you want ongoing management, like if you're managing a database that scales horizontally, you probably want a controller. But for most deployments, it's okay just to have a static file that you interpret at maybe build time. So you go through your pipeline takes the values and it says, oh, these fields mean these things. And we can keep it running to that specification with our own type of controller or CI/CD process. But I think if you think of it that way, it becomes way easier to understand where Helm is a temporary solution for templating. You can get very far, but some of the best and most powerful systems get rid of the templating automation and introduce a new abstraction, which is very different than templating.
Yeah, it's very hard to disagree, but yeah.
He's going to start
So
writing a bunch of code tomorrow based on this conversation. It's not my fault, anyone that works at Unity.
That speaks to customize, right? So,
well, customize is also about patching something where you know the schema. So customize was mainly born from the idea that if you think about what most people are doing, you create your deployment object in simple terms, but you just want to change the container tag. Do I need a Helm chart for that? That's kind of overkill. So customize says, given the fact, and I remember early on when we were talking about this, we used to talk about infrastructure as code. And I remember when I saw these techniques, I was like, this is infrastructure as data. So customize leans into the fact that we're talking about infrastructure as data. Code is in the controller, still there, but the front end is no longer code in this world. The front end is data. So then you start doing data pipelines. Data pipelines means that you can take a schema, you can validate that schema with Open Policy Agent and Gatekeeper through remission hooks. The beautiful thing about infrastructure as data versus infrastructure as code, if you write all of your infrastructure automation in HCL Terraform, or you write it all in Ruby for Chef, then you have to rewrite it all the time depending on what tool you're using. Infrastructure as data, you have another situation where all the tools can manipulate the object and you can switch between them, even in the pipeline. So customize was built from infrastructure as data. You can patch, you can merge, you can diff. And then when customize is finished, what comes out is something that's ready for the next stage, which could be going to GitHub and being pulled by config management tools. But even that pull process, as the config management tool does this thing, it will be committed to Kubernetes, which will continue the pipeline through an emission controller, which will also get to do more validation and changes to the data object. So once you really start thinking about Kubernetes as infrastructure as data, then all the tools start to make sense. And it doesn't matter which one you use on the front end. Helm is a front end technology. It used to be an in-cluster technology until we realized how dangerous that was. You want to push things like this on the outside, generate the assembly, and then other tools can be combined to create pipelines.
And in this model, what is JSON then?
JSON is also a front-end tool.
Okay.
So the way I think about all Kubernetes manifests, YAML files in Kubernetes are assembly. If you want to expand the assembly, just like we do with CPU architectures, like when Intel introduced AVX 512 to make machine learning and some mathematical operations better and faster, then you need a new CPU. In the Kubernetes world, the way we expand the CPU or the instruction set is by creating CRDs. So that means now in the computer, AKA Kubernetes, there's a new instruction set. This is all low-level YAML. And then anything in front of that, KSonnet, Helm, it doesn't matter. They're all front-end things, and their job is to make it easier to generate these instruction sets. But they are not authoritative because Kubernetes doesn't understand JSON. Something has to boil it down to what the computer can run. So Kubernetes is the authoritative. No matter what you do on the front end, there's only one thing that runs in Kubernetes, and it's not YAML, and it's not JSON, it's protocol buffers actually, right? So that's the low-level data format that gets stored in etcd, and everything else is either serialization layer or front end to generate the things that can be serialized into Kubernetes.
I have a question. Thank you very much. Thank you for answering the previous question, because I'm always afraid when somebody with PhD in computational chemistry asks the question, if I would be able to answer that question. And I know what you think, PhD in computational chemistry, it's Breaking Bad, but in the cloud. So that's at least my thinking. Second, thanks is for contributing to the open source. Thank you very much. And finally, my question is, there are plenty of companies which are behind these safe frameworks. Like they associate 5,000 employees, 7,000 employees, and they are still doing the baby steps in order to do proper open source work. So naturally what follows is to start doing the inner source. But inner sourcing in such a guided companies, it's still problematic issue. If you don't have push from the leadership, you cannot start the inner sourcing, hence you will not follow open sourcing. So my question is, what would be pointers that could facilitate the inner source movement and open source that will transfer into open source movement? Yeah.
This just boils down to leadership and people. If the person at that company has the most authority to say no, then that's what will happen. It doesn't matter what right or wrong is. If I'm the leader of engineering and I say no, then that's it. What are you going to do about it? You have to get rid of me. But there's a saying, sometimes progress takes someone leaving. They actually say something else, but we'll just say leaving, right? So when the person leaves, then the gate can be open. The way most companies are structured is very hierarchical. We still have this old school boss mentality. I am the boss. Even if I don't have the right answer, I'm still the boss. And so I say no. Why do most leaders say no? Because it's working. I don't care about optimal. Hire 50 more people. Hire 100 more people. Just keep doing what you're doing. Don't care. Because if you quit, there's another 300 people. They will do it. And if you won't do it, Accenture will do it. Google Cloud will do it. Someone's going to let me do exactly what I want because they take money. So it's a human leadership problem. If you believe that inner source is helpful, you will just make it happen. But unfortunately, there's a hierarchy. So if everyone on the team wanted it to be, and someone at the top that can fire you all says no, then the answer will probably be no. It's unfortunate. The people who actually understand the value of this, they implement it and they get the returns on that value. That's all it comes down to just who wants to make this decision. The other one is there's a lot of fear because you have to also have responsible engineers because sometimes engineers aren't responsible. They don't understand the business impact of copying code from Stack Overflow, bringing internal, and then the company ships it to a proprietary product. And now they're violating the GPL. So this is a problem because honestly, it's not just the leadership fault. A lot of engineers are uneducated about business and politics. They believe those things don't matter when it comes to being an engineer. So if that's the mentality, if that's the attitude, I cannot trust you with contributing to these other things because you don't understand the ramifications. Engineering is also a contract with society. Most engineers can get hired being very ignorant of those two things. And if I know that my entire staff is ignorant of those things, there is no way I can just let them contribute without a lot of oversight. So if I tell the team, you can contribute to open source, then I'm now responsible for what you contribute. You can bankrupt the whole company by contributing the wrong thing. We're done. That's it. You've seen what happens when people put security credentials in GitHub? Think about this. Your team just says, oh man, I'm tired of typing in this Amazon root private key. Put it on GitHub. It's private repo, right? This is dangerous. Some people have also made the mistake where they actually compile the private key in the binary. This is crazy. So to be fair to all people involved, if we want to see inner source work, then there's going to have to be a maturity at all the levels to say, you can trust us. So how do we do this at Google? We have this OSPO team, and they have lots of automated tools that look at all the open source things to say, hey, Kelsey, you're contributing something that could be a little dangerous. We have an agreement that we will not publish that type of code. So just so you're aware, we shouldn't do that. So we have a trust but verify for the most part. We have a path to contributing. Internally, engineers can move around quite a bit. Engineers depend on each other, and we have a culture of, if you need something, then you're free to contribute a fix there. But we also have a really good code review process. We have a very strict way of making changes. Some people think about it as we submit code twice. There's one where you submit your change, and that change is sitting in this buffer somewhere. And then we have very good rules around someone who owns the project has to look at it. Someone who understands the style guide, AKA readability, also has to look at it. These two people are required before the merge happens. The whole system works this way. It's very hard to side channel this. That's just how the system works. So, and then all the tests run, they just have to. And then once all of this is finished, then it's submitted again. And the other system makes sure that all of these things actually happened. And if they didn't, then it will be rejected. If you don't have that in place, the inner source thing can become very dangerous. One employee just got fired, but no one revoked their credentials yet. But wow, he's about to make a large scale change real quick. That can be very dangerous. So I think the bar, when we think about this as professionals, do we have all the right things in place? So if I were you, if I was at a company that wants to practice inner source, I'm not going to just say, I want to do inner source. I will present where we are from a maturity standpoint. More than likely, you'll see the big gap and say, ooh, before I go ask for this, maybe I should ask for better code review tools. Okay, who would turn that down? Maybe I go ask for all the things to reach that maturity level. Once I have all these things in place, then my next question will be, I think we're ready to do inner source, let people see more things because we have good tools to limit access on viewing and committing. And our change review process will not let people commit without proper review. Then the answer becomes, yeah, I mean, why not? We're already 90% there. Sure, let's go to the last mile.
Thank you.
And today, the developers are not just going to Stack Overflow and finding some code and copying it. The code is being generated by GitHub Copilot, right?
Which is essentially doing some of that, right? It's being trained on certain data sets. And that gets into a whole new world where some languages didn't have a standard library. So you have to go find examples and you have to bring it in. Languages have large standard libraries now, and they evolve over time based on what's happening in the community. A thing that one developer wrote becomes a standard library thing at some point. I think GitHub Copilot is just reminding us of how much repetition our field really is. We think we're doing something super amazing, right? What are you doing for the most part? Get a request, deserialize the body, map it to a type, do some small business logic, generate 2,000 gigs of logs, stick it in a database or Kafka, and return a response. Most people are doing exactly that. So it shouldn't be surprising that when you start writing that same boilerplate time for the 50th millionth time, that Copilot says, are you going to do this again? And you're like, oh, it feels like magic. No, it feels obvious. Right? That's all we're doing. And then that stuff will turn into frameworks at some point.
And I think we are on time for a break.
Okay, let's do it.
If you're hungry or thirsty, we have food and drinks over at the corner. And we will return in 20, 30 minutes.
Awesome. All right.
Yes. Welcome back, everybody. Are you ready? Hello, 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 hello. 1, 2, 3. Can you hear? Probably not. Yeah. Okay, so we hope you have prepared a lot of questions. We have almost an hour for asking. So any volunteer to bring the first question?
You ask a question, you get Gmail.
Don't be shy. Yeah. Maybe some Google Cloud credits.
All right, you have to ask questions because these are way more interesting when we get questions from you all. It's always more interesting, at least for me, to know what you care about. And of course, I'm just going to give my opinion, not necessarily the authoritative answer. But these are the most exciting thing about flying all the way from the US. Are you feeling guilty yet? Is to come to be here with the actual people. We can't do this on the internet. And so we're here. And if you have a question, it can be a range of things too. It doesn't have to be about just Kubernetes. It doesn't even have to be about just CNCF stuff. But the whole point of this is, the people are here. So please ask your questions.
We were just at the DevOps conference in the start of the week, and one of the hot topics were platform engineering. What would the next hot topic be?
I don't know. I don't know. I think so. Platform engineering, the reason why it's a hot topic is because it messes with people's identities. Right? We've all been doing this for so long. The words keep changing. And whenever the words change that puts us into the Venn diagram, then we all get excited again. And then people leave us alone and then we don't care anymore. It's like, oh, that's not me. That says data scientist. Data, not me. But when they come for our world, then we get excited. So only in our small world do we think that this platform, what does it even mean, right? We have a tradition in tech companies of saying, I'm going to use the technology required to service my customers. That's the requirement. So when mobile devices came, now you have to go hire mobile developers if you want to have a custom experience. And then so that field will mature and grow. On the backend side, especially the backend side, where this platform discussion is happening, what is the platform? Because when you think about a business, the business says, do everything. HR system, taxes, APIs, gaming, billing systems, whatever we think we want you to do. And so the IT department has traditionally said, we tend to manage things. If you buy it, we will manage it, not innovate, manage. You order Jira, we install it, there's a new version, we upgrade it. And so what happened with the IT department, they just started buying more systems. So you look around, you have 500 people in your IT department because they have SAP, Oracle, Jira, so many things, they manage it. And so that becomes their job full-time, managing. The hard disk has failed. Call Dell, get a new hard drive, and have the vendor come replace it and watch them get the old hard drive and destroy it. That's all IT. Now, platform is different. Platform says, the thing we need, we can't buy. Because if I can just buy it, then we'll just give it to the IT team or just do SaaS. Things that don't fall into that category goes to the platform team. We're Disney. We want an experience that doesn't exist yet. Netflix is okay, but we have a different vision for streaming and the experience that we want. So now I come to my platform team and say, I need you to figure out what's available. What can CDNs do? What can CDNs not do? And then that work falls to the platform team. Now the question for the platform team is, how good are you going to make your platform? We know IT has the luxury of taking something off the shelf and just managing it. You don't. You can't just go get a bunch of VMs and say, all right, we manage the VMs with Terraform. That is not what we're looking for from the platform team. Platform team needs to build platforms for my developer team. They're creating experiences. So I have these two groups. I need to know what the API is. In some companies, they've taken the management team, system administrators and et cetera, and said, you are now the platform team. But the APIs, they're not used to exporting APIs outside of SSH, Linux, Puppet, Terraform, but not a true platform. So we go all the way to the developer. So if you're a game designer, do not create a game engine. I need you to use the game engine. And I'm gonna have people creating assets, creating stories, thinking about gameplay. That's what I want those people doing. If those people are over here messing with Kubernetes, stop, whoa. You guys are too expensive to be messing with Kubernetes. So I think the platform team is, what we're seeing is a resurgence of the ask. Kubernetes and Helm charts is not enough to be called a platform team if you want to make your company successful. The real test is, I'm a developer and I'm building an experience for our customers. How hard is that? How hard is it? If it's too hard, then I need more from my platform team. The analogy I like to use is if you call a taxi and a taxi drives and they get out of the car and get into the back seat. And you say, all right, Kelsey, drive yourself. I'm like, I have no idea how to drive around Copenhagen. He's like, hey, too bad, self-service. That's not what I want. Taxi is a platform. The API for me is the back seat. The taxi shows up, I get into the back, I show the address, I check my email, they tell me I'm there, I pay. That's a really great API. So what is the API between platform team and your company? And it's not one thing. A lot of people say, oh, platform is using Kubernetes. No, that's one point. That's like tires on a car. What is the actual API between your development people, and the people using the platform. So that's why I think platform is so exciting, because now our identities are being challenged. The DevOps people is like, oh, I thought that was my world. Y'all not delivering. DevOps is not delivering on what people really expect now from the platform. So now we're trying to use a new word. Maybe we'll get a different result.
Is that Backstage?
Backstage, you can think about it as a platform. And I was just in Gothenburg with Nicholas, chief architect at Spotify. And we actually did a 1-hour interview just like this. And I was asking him questions about the evolution. I'll wait for the video to come out to drop into all the details. But I did talk about Backstage. And I said, before we talk about Backstage, which is a developer portal, IDP, internal developer portal. And when you think about what Backstage represents for Spotify, we'll see if it can work for the rest of the world. But what you think about it is, if I sat and watched how my developers work and all the things that they do, and I were to codify them into a workflow, you will end up with something that looks like Backstage. But what people don't understand is all the decisions that are underneath Backstage, the way they think about fleet management, the way they manage code, the way they create libraries, the way that they have their own architect. I think it's called Hermes or something. There's like gRPC for how you specify services, encode them, and the protocol they use to talk to each other. They have all of that. And so if you have all of that, they've been moving up the stack for 6+ years. And now they're able to produce Backstage because that's the only thing left to do to make developers even more proficient. How many times do you want to say this app can talk to this app? You could go to the thing and register the app and say, these are the things that are allowed to talk to it, hit save. And then that will generate all the IAM bindings, the deployment objects, et cetera. So I think for Spotify, Backstage is the serialization of the Spotify culture. What's going to happen though is someone's going to look at Backstage and say, oh, I want to be like Spotify. Have you agreed on protocols? No. Do you have automation? No. Do you pay engineers well? No. So then Backstage will just sit there and you will all be confused. So I don't know if you can just download it, but I think Backstage is a great example of what happens when an engineering team exports their engineering culture.
So we are trying to implement Backstage in Unity as well.
How's it going? Be honest, be honest.
Not as well as I hope, I would say. And apologies to the team members who are doing that work this year. But for us, how do you get started? And I think what you just mentioned, that you start by maybe having a unified way to call your APIs, to do identity and stuff like that. And that is actually some of the prerequisites to actually being successful with Backstage. Because if you just download Backstage and just deploy it and then tell all your developers to go and enter stuff in, it kind of becomes this additional work task that they do when they don't really see the benefits from it. At least not until enough people have put enough stuff into it that it actually starts to make sense. So in a way, it becomes another piece of documentation you have to write, and it's more becoming something that is keeping you from doing the thing you actually want to do. So I think the journey to a successful Backstage deployment is very hard and long. Depending on where you are, maybe if you're nearly already at the phase of that Spotify was.
And that's what we talked about a lot. And I think we all have to do this as technologists, ambassadors, part of this community. It's not just use this technology. What are the prerequisites that don't get put in the doc? What assumptions are you actually making for someone to take this thing and be able to use it? And I think that's the part where, as the technology matures, that second wave will be the people who can actually show all of these details. And that's when people have the aha moment, right? If you ever see me present at a KubeCon, I always try my best to say, before we get to the thing that we're going to talk about, let's rewind and show the assumptions that I'm making. And then you build back up to the big thing. And that is so needed, even for experts. A lot of people, I'm an expert. It's like, maybe, but you might be missing something in order to get adoption. I think there's a question back here.
I had a question. I think I remember you having said either today or in one of the videos that using Kubernetes alone does not make you innovative. You might get free time, but that's not the way you're going to be innovative. Now you have the privilege to work for a company that some of us might agree, some might not, is innovative. What's the secret? What have you seen works? What do the Google's engineering teams do to actually be innovative?
Yeah, like innovation is tricky because if we were really honest about that word, innovation rarely happens, right? Like innovation is like, wow, I've never seen that. Or you've taken two things that I've seen before, but you use it in a way I've never seen before. That doesn't happen very often. So I think number one, we should stop thinking about innovation as a common occurrence. The biggest problem is execution. Typically, when we see people execute well, that looks like innovation all by itself. You have an idea and you executed on it. That to me is process innovation. I think that is what most companies are struggling with more than just coming up with a great idea. Right? There's lots of ideas out there, but the implementation or the execution is the hard part. Not that innovation in terms of creating new ideas is easy and everyone can do it. It's the execution piece. So there's like when I meet people that use Kubernetes well, they never say anything about Kubernetes. Oh, it's just there. They always show me the thing that they're doing. They always pull up and say, if you want to do something in our infrastructure, if you click this and you do this, it comes up in 5 minutes. If it's idle for 30 minutes, we destroy it, soft delete. If it's idle for more than a day, then it's destroyed to save money. But if you come back, we bring it back. Wow. That feels innovative, but that's just masterful execution. Right? What's innovative about that? Right? You know that that probably should be the right way of doing things. So I think the key is, just like with any automation project, is what is the idea? What are the processes behind this idea? And if once you have that and you do that well, and it's going to change, how long does it take to go from that to in reality? That's innovation, because then you can try 50 things that don't work and it's not going to cost you 50 years. So the companies that struggle the most, they have to make bets. We have these two ideas. If we do one of them, it's going to be 2 years. And like we see with Meta, with Metaverse, right? What did they say? He spent 50 billion? Right? That's a huge cost. So most companies, if Facebook is having this trouble coming with a new idea, we've seen this before. Second Life. This is not the first time people have seen VR type things. But now what's I think that people are worried about is the ability to execute on the big vision. Now he's trying to solve a really, really big problem. But more to your question, you have banks trying to deploy software. For them, that will be a very innovative thing to be able to deploy software consistently along with all the rules that they've created for themselves and the regulators have created for themselves. Anyone that goes into a bank shows them how to take common things and actually executes to the point where when the idea is ready, it can be in front of customers in 5 minutes. That will feel very innovative to that one company. But if you told that story to someone else on the outside, they'd be like, oh my God, are you still talking about automated deployments in 2022? So that's the way I think about innovation. It's probably more about execution than it is a new idea we've never seen before. Great question, by the way. Ask me anything requires you to ask. All right, we'll go here, then over there.
Okay, I have a question. So we were talking about config management. So I've been reading a lot about Crossplane, and I wanted to hear your thoughts on that because it looks like a really awesome concept, but in terms of how it performs against Terraform and like the big state box, you know, kind of how does that all work? How do you think that works for Kubernetes as the back end?
So I'm a technical advisor to the Crossplane team. I have been for a year, maybe actually almost 2 years now. Bassam, I know the whole team when they were much, much smaller and they were coming with this idea. And so as an advisor, where should it go? I remember the first time I met the team, it was like, build your own pass. Like that doesn't make a lot of sense because the problem with passes are they need to be very opinionated. If you have a bunch of people just building random passes, like what is Crossplane then? It's just whatever you want it to be. So we have to be a little clear. I remember I was mentioning things like universal control plane. If you think about the web, you have a web browser, you have a web server. The web server sends HTML, the browser grabs it, and then you have headers, you have all these things. And then someone looked at that and said, ooh, that part is interesting, even if you don't have a web page. You can have backend services communicate over the web using HTTP, and we can use the verbs to create RESTful interfaces. So now we have this whole new evolution. But then people were just creating their own protocols. Essentially, if you're just using raw REST, the body, the schema, all of that is just custom protocols for most people in terms of what's in the body. And then you get something like gRPC, that rides on top of HTTP, and you get a new system. When I think about Kubernetes and config management, people will learn that you can do everything in Kubernetes without a cluster. It's just an API server. So if you take the API server out and you remove the nodes, because the nodes are not required, you have etcd for storage, you have the API server, and then you have these controllers for RBAC who can see things. Kubernetes, the KRM, Kubernetes Resource Model, is just infrastructure rest. That's what it is. So you take it out, and what can you do with this new RESTful framework? That's why we call it API machinery. So this is the RESTful framework. Well, we know for certain types of workloads like infrastructure, it is much easier for someone to tell you what they want. Like, you know, when you open a Jira ticket, hey, we want an S3 bucket. Well, what does it look like? What zone, what region, and how much money do you have? All of that becomes a declarative request, but you know, we put in a Jira ticket, you read the Jira ticket, and then you can run commands. But Kubernetes says, if you serialize the same request, you give it to me, and I will do absolutely nothing other than have it stored. And then we have the spec and status. For anyone that wants to understand configuration management, these two things are the biggest jumps in the configuration management landscape. The first time I came to Oslo years ago, right after Kubernetes came out. When Kubernetes came out, I was so excited. I was working at CoreOS, and we had a competitor. And I was like, I'm working on Kubernetes anyway in the nighttime. I'm contributing code, I'm writing documentation, and everywhere I would visit, I would just do random workshops. Hey, what are you doing? The flight is in for 3 more hours. We can teach Kubernetes to you right now in the airport. And that's what I was doing, at least. And people are like, why are you so excited? It's like, finally, we understand configuration management. So I'm in Oslo, and Mark Burris lives there, Promise Theory. And he created CF Engine. CF Engine led to Puppet. Puppet leads to Chef. And I said, I'm going to show you what I think is the perfect implementation of Promise Theory. And I showed him the deployment object with no nodes. And it sat there. He was like, okay. I was like, this YAML file is the promise. So you give it to Kubernetes and nothing happens because there are no nodes. There's no scheduler, but it sits there. And I showed him the status field. So I'm going to show you something amazing. I brought up the scheduler and a node, and it did a placement. And it wrote into the status field that it's been placed on this node. But there's no kubelet, but it's been placed. And he's like, wow, okay. The separation of these two things means the declarative state is never touched. It is always what you said. In Puppet and Chef, that's not really true. The agent does weird things to the thing, and it's like, I don't know what I said and what you did. They're merged. There is no status field. The kube has this abstract arbitrary field that lets controllers do their thing. And so now you can put a controller that takes the definition the same way we've been doing for a decade before, same exact concept, but it's data. Instead of mixing the two things, like putting if statements in the logic, we push all of that logic into the controller. That means anyone can just look at the data and predict what the system should do. That's the big thing we did different in Kubernetes world. So now let's get back to Crossplane. What does Crossplane say? What is its purpose? Well, we know that you can build any control plane using the KRM. Istio uses it for doing network management. Kubernetes uses it for container management. You can build any system you want, but there's a problem. It's hard. You have to watch the Kubernetes API. If too many things watch the Kubernetes API, it puts too much pressure. So then you need to cache. Caching is hard, computer science problem. People don't know when to bust the cache. And then as the controller is manipulating state, there is no guarantee that another controller isn't manipulating state. Then you have race conditions on who created the bucket or not. Should you have two things trying to create the bucket or only one? So then you need leader, like I am the leading controller, this one's fallback. Do not try to create the resource at the same time. So you see all the problems. So they came with an SDK. The SDK makes it much easier to describe a controller and also define your own CRD, and then they can generate everything else. So eventually that becomes Crossplane, a universal control plane. And when we decided like, hey, from a business model upbound, what are you selling? You're not selling a better Terraform. I remember when we came out to like the community, I was showing people that the evolution of configuration is you do it manually, you understand the process, and then you create a schema so the process can be automated. Terraform can always be pointed at Crossplane to just generate the binding. So you write HCL, it generates data, it gives it to whoever the control plane is, Amazon, Google, Azure. But in this case, the control plane is just Kubernetes. And then that control plane now has clear ownership separation. No longer is Terraform trying to inspect a live system. Terraform only says, this is what the user wants, and I will read the status field back to the user. Beautiful delineation here. And so really what you're selling a company is, what is the difference between most platform teams and cloud providers? Cloud providers start with the control plane. We start with the control plane. We have billing, we have documentation, we have command line tools, and they're all centered around the control plane. We just don't give you raw access to the underlying sources. And so Terraform is something that calls control planes. So whether you're using Crossplane or your cloud provider's control plane, there's less overlap than most people think. So Crossplane is more about being your own control plane provider. And the reason why people like Kubernetes is because when you have this model, now you can do policy. Policy is hard in HCL because you also have to be a parser of HCL. It's hard. But when it's data, then policy is more of a pattern matching thing. If I see this data element, does it match the policy? If no, reject it or merge a new thing in place. So that's why I think Crossplane is perfect UX for this workflow we're talking about. Last thing here is I've seen maybe 10 startups now. They don't know it, but they're all working on the same thing. And the thing that they're working on is virtualizing Kubernetes. Kubernetes is not a multi-tenant system. You have namespaces, but it's not multi-tenant from the API standpoint. And so to make it multi-tenant, you actually need like virtual API servers. And virtual API servers will basically give you, and implementations work differently between the people I've seen trying to build, but they're more like proxies. You have a virtual API server where you write API things to kubectl to, and then that thing will evaluate policy to see if it's safe. And if it's safe, it will create a new object behind the scenes with a really weird name and map them together. And so now you have strong isolation at the API level, and then you have this thing at the bottom. And kernels work like this, like gvisor implements the kernel and user space. So apps talk to gvisor, makes system calls, evaluates it, and then the kernel can run some safer version of that. So once you start to have virtualized Kubernetes API server, and you get rid of the cluster, now you have true control planes. And even HashiCorp realizes this. That's why you have Terraform Cloud, which tries to move more into this always on model. And to be fair, a lot of cross-plane controllers are just Terraform. People are taking the YAML file from Kubernetes and then calling Terraform, getting the data back, and then putting it back into the status field. But that's the relationship.
Let me try. Oh, okay.
There we go.
Thanks. First, for your phone's on the floor, you might want to pick it up.
Listen, do not disturb, so I'm not going to bother it.
I heard you mentioned about GKE is the best in your opinion. If we talk to different sellers, they will tell different stories depending on the town.
Hold on, if I said GKE wasn't the best, y'all will know I was lying. I mean, I touched them all to make sure. Like seriously, I don't ever want to say something that you can easily verify not being true. Because the thing that makes GKE very unique is, in Azure, AKS is this, I think, the closest because of their design philosophies. When you say, give me a Kubernetes cluster, I expect the nodes to be managed. There's nothing wrong with EKS, but when you click the button, you're like, where's the nodes? And then it's like, hey, go use this thing or this other thing, and you can create nodes. There's nothing wrong with that because there are some value to be able to have a custom node object. But when people say like a Kubernetes engine, you kind of expect this level of management all the way through the stack. For example, when you go to GKE and you click the export metrics to BigQuery, and you go to BigQuery and you see all the metrics from all your clusters, you're like, wow, something is different here. Right? When you say, I have 5 clusters and I want multiple ingress controller, and we have a control plane that says, I can do that with an anycast IP, Or when you say kube DNS isn't scaling for me, it's falling over. And we say, don't worry about it. Create this cluster and map all the DNS to the VPC. And now you have cross-cluster DNS with no collisions. When you say resize the cluster and you have non-continuous IP space. So when you create a Kubernetes cluster, you have to make some decisions. How big is the IP pool? Because the API server has to be configured with it. GKE also suffered from this problem. You create 12 clusters with too big of an IP range, that's it. You're out of IPs for that whole region. You're finished. And then what we decided was, number one, we're going to open the IP space you can use in GCP in general. Second was, we're going to allow you to resize the cluster using non-continuous IP blocks. This is hard. We've changed GCP itself for Kubernetes. The reason why it's very different. The first time we did Kubernetes in GCP, I remember VMs could only mount like two or three volumes. Because why would you mount 40 volumes to one VM? It didn't make any sense. But when Kubernetes came, it started to make sense because that's what container needs. When you're pulling a container image from a repository that's 50 gigs in size, there's a thing you can do with the kernel, just like you do with a normal process. When you have the first parts of an ELF binary, you can start streaming it and then it can start doing things. Well, we have a whole file system just for this called Riptide that allows you to start running containers while it's being streamed. This is a feat of engineering that's beyond what you would expect from a normal Kubernetes cluster. So when you start to add up all these little things like the node problem detector that knows that Docker will sometimes freeze, but you don't need to really restart the whole node, or you pay attention to single bit memory errors and you know that this node needs to be rebooted, or you say there are pod disruption budgets and I should slow down the rollout of new versions because we are respecting the pod. It's just a different dimension. And so, yes, there are other Kubernetes offerings that you click the button and Kubernetes cluster comes up, but then you're on your own for all of these small nuanced things. That's the only reason why I say that, because I think the team has earned that right. And so I go and touch all the other implementations and say, we ain't quite there yet, right? So that's the only, I just want to make sure I defend it because I don't say lightly, right? I'm always honest and transparent as I can be. And look, if I've described something that is commonplace in all the other ones, I'd love to know. I just haven't seen it yet.
That's great. If it's okay, I can add one more questions. Now GitOps and together with a cluster API seem to play a great role and have gained a lot of attraction. Is GKE also gonna go that direction, have a certain offering where can combine those two technologies together and support them?
Again, this is the same thing HashiCorp did. In the beginning, there was one VM type, right? Because everyone thinks there's only one way to configure a GKE cluster. When GKE started, I don't know, 10 flags, there's probably 100+ flags now. Do you want TPUs or not? Do you want to support NVIDIA with a custom device management so we can actually share one GPU into 7 different containers? The relationship to the node and the driver must be that tight. That's not a normal thing. Who else is doing that? So Cluster API will only be able to describe the most basic things. I want this many nodes, maybe with this much memory CPU, but it won't say things like, I want a node that's based on ARM only in this region that uses my sustainable usage discounts with this node template that fails over between regions, only if the volume is available, because this workload supports regional dis. That's a lot. So we keep doing this as an industry. People look at the common case and believe we should bake a whole standard on it. You can try, but what will happen is you're going to have a problem where you want to do just one thing different. I can guarantee you right now, the cluster API will split into specific types. It's just like when you write code. Oh, this is the perfect wrapper class. No one's going to ever need anything else at this company because of this base class. Then before you know it, not only do you have 10 versions of this class, there are some people that have just abandoned ship because the class is so complicated. They just wrote a whole new thing. In the case of Google, we wrote a whole new programming language called Go to rewrite some of these services in for simplicity. So I think Cluster API is a good step of saying, what should be the baseline of telling a provider that I would like a cluster? But these days, that's not the hard part, right? I think we always confuse the fact that if I know what the schemas are and what my options are, the first challenge will be learning those. and seeing what I can do with them. There's value in them being different. And if we normalize them into a full commodity, that means it will only work when we all stop innovating. The minute all cloud providers stop doing anything interesting, like auto scaling, vertical pod auto scaling, that's not normal. When that all stops, then this will work. It's just going to be frustrating in the meantime. So I like it. It makes sense. Byron, we've seen this movie 8 times. We saw it in the theater. We saw it at home. I even watched it on the plane. I know how it's going to end. It doesn't mean people shouldn't stop working, but I think we need to be intellectually honest. What we are describing as an 80% use case, it's going to work for a lot of people, but until you get serious and you start to realize the reason why you're running on Amazon GovCloud is for a very specific reason. And those flags are going to be specific only to Amazon GovCloud and applied nowhere else.
Thank you. I think I got even more questions in my mind after that.
It's not a bad effort. Anyone working on this, I'm not saying you're wasting your time. I'm saying is you have to be very clear about what we're doing. We did the same thing with Ingress and we ended up with a bunch of annotations. We did the same thing with VMs and then we ended up with cloud provider types. Just understand, build this stuff to accommodate change. And so if we're smart, what will happen is if we are intentional, then the add-ons will just be a merge, like customize patch GCP, and I can keep the baseline because I'm going from VMware to GCP, but then I have a customized file that patches the rest of it because we're thinking about that even being a core use case, right? And then it'll be fine.
What are your thoughts about creativity in operations? Like we talk about let's have dumb deployments, and then at the same time we're creating our own platforms even though we are not calling them, and that means it has shit ton of logic in there and we have to maintain them. We just talk about we're not interested in for instance vendor lock-in. At the same time we have created our own everyone has created their own platforms, deployment platforms, even though we don't call them, and we are locked in there. And we have to, and God knows how we can move out of it. So what are your thoughts about it? Is it a good practice? If it is not, what do you think we should do?
Yeah, I mean, when I think about creativity in the platform world, it comes from constraints. We don't have all the, if you had all the money in the world, then you just spin wildly. Why turn anything off? Why scale to 0? You just have unlimited money, just do whatever. But I think in the platform world, we get creative when we think about restraints. For example, I've seen people create emulators for COBOL so it can run on Linux. It's very creative. They're doing that because they don't want to buy any more mainframes. So they found that it was easier to create an emulator for that layer. Man, I talk so much. Refill the battery. So when you think about that creativity, I think that is the value of good engineering, is that people can look at a problem and say, I know what we can do here. I've also seen people do too much. People spin up a whole Kubernetes cluster to run a workload every 5 minutes. So I'm going to show you something real cool. They're like, what? I'm saying, you got to be ready though. You got to sit down. And I created a VM and a cron job. And it ran it every 5 minutes. It was cheap as hell. They're like, wow, that's it? I was like, yeah, that's it. But I want to do it in Kubernetes. I know you want to do it for your resume. I know you want to do it for the LinkedIn. But this is all you need. And they get sad, right? Because the problem is now solved. So I think anytime simplicity is one of these things, when the abstractions change, you have this opportunity to get creative of combining the right things and making it happen. So my thoughts are on that. And then lock-in. Lock-in, the only thing worse than lock-in is lock-out. People hate Oracle for the wrong reasons, actually. Yes, they keep charging more money. So do I. As I get better at what I do, I start charging more money. Y'all should try it sometime. It's really excellent. So most things in the world that get more valuable tend to go up in price. That's just how it is. You do it too. Sometimes the problem with Oracle, though, is the lockout part, when they say you cannot run that on VMware. You cannot run that on GCP. So that's a problem. If you're being helpful and I can use it everywhere, it's almost indistinguishable from open source. You just don't care. One just has a fee to it. And their track record has earned them a lot of trust. Oracle's been around before I was born. So the track record is there. When it comes to open, the things that make things become locked into your platform team, or your platform team will lock you out. I'm gonna give you a good example. You're using Postgres, so you think. Your platform team got overly creative. They start creating custom extensions in Postgres. Like, what the hell is that? I didn't even know anyone on this team knew C. And so you got all these weird ass extensions that are now powering the business. Some of this stuff could have easily been in the app code, but no, we're gonna write a C module in Postgres to do it. It's been fine on-prem. And then one day in the future, the cloud provider will be able to run this workload of database for free tier database. That's all we need. And you're gonna be telling your team, well, we can't do that. It's like, why? It's Postgres, right? It's like, yeah, it was Postgres. And the extension we wrote only worked with Postgres 10.3.1 from Red Hat. You need all of those patches. If you try to use Postgres 14, it will not work. So now what's the value of open source in this scenario? So I think platform teams have to think about change. So the one thing that I've learned a lot when I was at Google, when you look at the product description docs, PRDs, the thing I like the most, not just the formality of writing it down, the part where you say, here's the assumptions I'm making. And if you're really good, you're saying, here's the switching cost. I'm going to write this extension and you will never be able to switch off of this. You still want to do it? Probably not. So I think when we think about platform team, what are we building? And I think there's a comment saying you cannot get married to the things you've built. A lot of platform teams are holding their organizations back because that core group is literally married. I've seen in the early Kubernetes thing, I remember when I was showing some platform teams Kubernetes, they're like, oh, we've already built that. And I was like, show it to me. And they would show me this thing, and it was like 7,000 lines of bash scripts. And it was like, it's bash, it's cool, and it was working. It's like, so we don't need anything. And then I would come back next year and say, hey, you have RBAC? We don't need RBAC. I said, okay, you don't need RBAC. Do you have a scheduler? No, we just put one app per VM and it's fine. It's costing us, we're only doing 8% utilization, but no one's complained yet. And so the whole world is moving in this other direction. And here they are on this little island. And then one day the company says, oh, we got this Kubernetes manifest from the vendor to make life really easy. And you say, oh no, we don't support Kubernetes and this thing. So what does your thing do? Well, we can add support for it. We just need to hire 700 more people and we need $1 billion of investment. Now you're holding the organization back at now at that moment. So now you have to make a decision. So I think as a platform professional, everything you're doing is temporary and it's only based on today's assumptions. Don't overbuild for like a future you that is unknown, but just know it's going to change and at least leave a breadcrumb trail to say, we do this. We have the potential to lock ourselves into this open thing or to these few people who understand
it. So security is pretty tough. You know, we write these systems that you depend on thousands of different sources of code. We have left pad and so on. And it seems as we're moving forward in recent times, there's some signs of improvement in the security story. There's more YubiKeys. There's talk about single bill of materials. So what do you think of the future of source security and source provenance? And can we create like secure build systems where we know what you've built?
I like this question. Someone asked me to give a keynote at the NIST conference, you know, this body around security. And they wanted me to talk about zero trust. I said, okay. Not that I know everything about zero trust, but I know enough. And I looked at the agenda and the person who came up with the name zero trust was speaking after me. I was like, this is going to be real bad if I'm describing it wrong. But I said, you know what? I'm only going to try to demonstrate the reality. And so I remember giving this demo of building trust from the ground up. And the first statement I made, just from working at Google as well, where it's a very common practice, but in the real world is how I try to explain it through live demo. And I said, what I've learned so far over the years, zero trust is not possible. It's impossible. You cannot do it. And I said, I'm just going to live with that statement. And in the chat, the other person was like, Kelsey is 100% right. And he repeated it in his opening talk. What Kelsey said was true. And from my learning, it's about removing implicit trust, just the things that we take for granted. Let's just remove them as we identify. So let's think about another extreme, Wasm. You have this web browser. And back in the day, before we had the strong isolation from like Chrome and V8, JavaScript was just doing random stuff. On one tab or one browser, you're in your bank. And then in another tab, you're on the trust us, we're not doing bad things.com. And you have that tab open. And behind the scenes, there was JavaScript like, is there a bank account open somewhere? And it found it. And you go to the bathroom, you come back, your bank account says 0. You're like, how the hell did this happen? The other browser was doing stuff to the other thing. And so we created this tight isolation in the browser, the V8 runtime that says you can only do these things in a very tight sandbox. We don't need to implement a whole kernel. We don't need to have accessing random files, networking, scraping other screens, and they locked it down. So we zoom back and say, damn, what did we learn from this journey? Apps today, most people have no idea what they're doing, right? I need to build some code. I go to GitHub. I say, damn, that's a lot of GitHub stars. This must be safe. Who would star something that is not safe? So you import it, and then it imports some stuff. And as you're watching it import stuff, right, you're like, damn, that's a lot of stuff. I don't know, man. I don't have time to look at all of that. I trust these folks. And so now you have this ticking time bomb that you're about to go to production because ain't nobody else going to check it either. So the things we build today, we have no idea what the hell they do. We're just hoping from the best. So then we go to platforms like Heroku, Kubernetes, and we put the Oracle password in an environment variable. And that library is like, damn, is that an Oracle password? This is cool. Maybe I'll just send it somewhere else. And your networking team is like, as long as you send it over HTTPS, we're fine. And so the library sends it over HTTPS. And then you have all these other problems. So what do we need to get to? And you look at Kubernetes as a good stepping stone. Kubernetes, I remember the first time some people took like their Java app and they realized how untuned the JVM was out of the box. Or they go in there and we talked about this earlier during the break. CPU limit equals 3. And the JVM says, I don't care what that means. I'm spawning 64 threads and I'm gonna take all the RAM too. I can care less about what you're telling Kubernetes. I'm gonna take the whole box, and then it gets throttled or it gets an out of memory exception because of the new counting mechanisms in the kernel, and it falls over. But the takeaway from here is that what if you were to specify everything your workload was supposed to do? So imagine now writing code where you say, this library only makes these 3 system calls, right? You import the library and the documentation says, this has been tested, this library only makes these 3 system calls. So as a developer, wouldn't it be nice to be able to say, this app for what it does, take in data, deserializing JSON, transform and put in a database and return a response. That's what most people are doing. How many system calls do you need to do that? You don't need so many. Wouldn't it be nice to say that this binary only needs these 5 system calls? If you're using something like gRPC, it should only receive this data. If it's not this data, don't even send it to me. It's just bad. I don't know what to do with anything else. So imagine as a developer, you were able to say, these are the only inputs and outputs ever. And these are the only system calls ever. What if that was the contract? I could generate SD Linux policies. I can generate the Kubernetes policies. I can generate the firewall policies. So if we started security thinking from that regard of this is the only thing that this thing needs. So security typically is a function of writing software that does what it's designed to do and only what it's designed to do. That's the end game for security. And so all these places where we try to do this, that's what makes this hard because we don't know what these softwares are trying to do. We're just observing them and saying, oh, should we be exporting other people's user data under this thing? Like, I don't think so. I mean, no one knows. Nothing's turned red. Prometheus is happy. Maybe someone's writing a report. That's the way we live in today. So if we get a little bit tighter on the thing, and the Wasm community is already there, right? They're just saying this runtime only allows these things. So what do we get as a result? Cloudflare can now run untrusted code in the CDN, in the network path, with very little fear that one customer's thing is going to deal with traffic for another customer. Can we do that for the backend? So that's the way I think about it fundamentally. As a developer, the thing that we're building, can we get there? The mobile space is also doing something like this. You install a mobile app and it doesn't ask the developer, it asks you, do you really want this to access your photos? Did you know it's using your location? We can cut that off because in their documentation, they've said that they wanted to do this because we only allow these SDKs. And now we're informing you by generating settings external because that's all this app should be doing. So I think we have to progress to that point, and then all this other stuff just becomes configuration tools to enforce these requirements. I don't know if that answers your question, but that's the way I've been thinking about security this whole time. So Istio is just another place to enforce some of these things. Only this app can talk to me. Well, the next level is, well, what should it be saying? We need to define that.
Anybody else?
Don't worry, we just go to backstage and figure out what the app should be saying, right?
A follow-up maybe. Do you believe then that Wasm is going to be powering backend services like the Fermion team with Spin think?
I mean, they could. I mean, at that point, then you're going to invent the JVM all over again. Because the more you add to Wasm, file system support, networking support, socket support, right? What if you need to have a multi-threads? They don't, that's not a thing today. So by the time you add all of that stuff back, then those will be probably attack vectors to do something bad. Yeah. And so the question, I think they're starting from a better place. So they're just going to add the things needed. The kernel is trying to remove the things that are not needed, but there's a lot of things there because it's general purpose. Could they do it? They're working hard at it. And the future will be defined by the people working on it. So if they're going to continue to work on it, my guess is there will be some backend things. I mean, Docker just announced that they're going to take Wasm workloads and instead of calling container D under run C to launch a container, they can call the Wasm runtime and let the Wasm runtime run the thing that's in the container image. So we know it's possible right now. It's just the thing that you run in that Wasm runtime is not going to be able to do more than what you can typically do in a web browser. So that's going to be up to that team to decide how big does that new computer get.
But they're doing this for security and isolation, or is they doing this for extensibility purposes?
They're doing it for security and isolation because that's where it came from, V8, right? It comes from that world. That's why it was invented, for that purpose. But you get some benefits from this lightness. You get fast startup time, right? So if you're a Cloudflare, I can now run something fast. So then the question to your point, why is Cloudflare caring about Wasm? Well, I have, in many ways, a load balancer proxy product. I'm never going to build all the features in the world, so I need a plugin system. Man, this is a great plugin system because if you think about what a proxy is and the stuff that it's supposed to be doing, it looks a lot like a browser. And so if it works for Chrome, I can take the same runtime and stick it in the proxy itself. And you can run the same JavaScript isolated things. I think they did a good job by saying, it can't just be JavaScript. We should support Rust. We should support other things. So I think we've learned to define that base layer, not just from what a browser needs and the DOM, but what is safe to do in the isolated thing. I think in the gaming world, hey, we have a gaming engine that already works well. If I can just target Wasm, because I don't need a whole computer, but if the browser is going to give me enough of a computer, then I can now run native C code or C++ targeting Wasm instead of ARM64, you get the same thing. So the byproduct, though, is speed. The byproduct is a great plugin system. Unlike, dynamic linking and foreign function interfaces where you're calling code in another language, that becomes very unsafe. So I think that's why it's just the pattern's taken off.
Hey, yeah, I'm audible. So first of all, thanks a lot for all the awesome insights and reflections. We've already touched upon Crossplane a bit and virtualizing the Kubernetes API server. And you also already mentioned that you've spoken with a lot of people on this mission. And I've personally been looking a bit into the KCP project. I think Clayton Coleman and Comac, maybe Coleman, and other folks are interested in this world. What do you think it will do when we can actually abstract away the physical nodes where we are running our workloads and can focus on the controllers and extensibility of the API server more in a general sense?
Yeah, you know, when we were designing GKE Autopilot 5 years ago, lots of people had lots of ideas. One of them was like secure by default. Turns out if you do that, most workloads will not run. The other one was, we were thinking of like serverless Kubernetes. And so the one big anchor was the nodes have to be hidden from the user. Unfortunately, you can't really take it away from the Kubernetes API, but you don't have to respond. You don't have to tell kubectl that there's any nodes there if you don't want to. So that's optional. So what happens if you do that though? Well, step one is the way we write software these days, you have to know about the target machine. Is this AMD 64? Actually, you may even need to know what type of Intel architecture, because I'm using a specific construction set. So as a person writing code, I may still have to communicate some metadata that I really need this instruction set. If I cannot get this instruction set, then I can't use it. Or I need a GPU. I have to express to the scheduler, I need a GPU in this model. So that contract, I think, is going to have to be there because of how we write software. The software is an intimate relationship with the hardware, especially when you're using accelerators. So given that nature, that will still be there. Now, Kubernetes has already started off on a good foot. You usually don't tell the cluster what node you want, but you can. You can say kubectl get nodes, get the node ID. And when you write your deployment, you can actually say node name equals, and then Kubernetes will just put it there. But most people don't do that. So that set the stage for autopilot, where you can take the nodes away, hide the names, and just give the workload. So then what happens is for the container deployment case, you end up in a world where it feels a lot more like App Engine. The funny thing is this is not new because in the cloud, we never expose the hypervisor. No one thinks about the hypervisor, right? You just said, give me a VM. And a VM is analogous to a pod, right? You don't say, oh, I want this hypervisor by name. So in many ways, Kubernetes was a step backwards by exposing the hypervisor, quote unquote, the node, in addition to the workload. You ever see people do this trying to auto scale? It's like playing musical chairs. You scale the pods, but not enough nodes, right? Too many nodes, too few pods. And then they're trying to scale 2 layers. That has never been a requirement in the cloud before. The cloud has always said you only scale 1 dimension, which is the VMs. The cloud provider deals with the hypervisor. So autopilot is actually, for the first time, giving you the normal cloud experience of only scaling the dimension that you should be in control of. But we need data from you. So if you look at the VM API, you say, I want Intel family X, and then we encode that into a machine type. That's what's going to happen in autopilot, because now customers are asking for more metadata to describe more details about the machine so autopilot can make a better decision when it's provisioning and scaling. All right, the next phase, when we came out with the config connector, you talked about at Unity, they're using this to do things like create a GCP bucket, right? This is cool, you have a declarative interface. And I remember seeing the design, it's like, guys, what's the first step? Create a cluster? I don't know, man. All I want to do is create a spanner database. If I use G-Cloud, data spanner, create, boom, easy. Terraform, create, easy. But you're saying, hold on. We need a whole Kubernetes cluster first. It's like, do we really? What we want is a default control plane that I just give them to. We did this once already with Cloud Run. Cloud Run implements the Kubernetes resource model for Knative objects and for Cloud Run native objects. And so what happens is there is no Kubernetes anywhere in the Cloud Run stack, not at the node level, not at the API level, none of it. It's just normal GCP API. So you can say G-Cloud run submit the object. Our control plane parses it and then just does the right thing in the back end. So I think going forward, what you will see from other providers, they will support the KRM, but with no Kubernetes, because you don't need it if it's just a control plane. So hopefully that answers the question that once you get rid of the nodes, things get interesting. Once you get rid of the machinery, things become familiar, just like existing control planes today.
I think we have time for one question more, so don't be shy. Yeah.
It's me again, sorry. For me, it's easy to be inspired by listening to people like you and around. So I'd like to know who inspires? Where do you get inspiration from? What do you read? Where do you recharge batteries? What drives you? Simple.
I get inspired by people who think being nice is a strength. When I see people that are like starting their journey and you can look at them and they have so much hope about what the world is because they don't know yet. They don't know how mean people can be. They don't know how political your manager can be, but they know that they want to get in this field. They want the opportunity to create things. And I get to talk to them while they're still in that state. And I get to tell them there are going to be a lot of people who no longer feel like they feel, and they're going to try to invite you to their misery party. Do not go there. Even if it's your boss, you got to figure out how to create a firewall between that and where you want to go. And then those people will send me an email a year later and say, hey, I made it to where I wanted to be. And the most inspiring part, I didn't forget what you told me because I told it to these 3 other people and they work with me. That to me just shows me that there is room in this system for people that are being genuine, that want to succeed. I'm not saying it's easy because we still have too many people that think the world should be hard and miserable. I don't know why, but some people live for that. But when I think about like the world of open source where you can create things without permission, your boss can't say no, it doesn't matter what the competitor thinks, you literally can open your IDE and create something. If people like it, then they can join. If not, it can be just for you. That is very inspiring to me. Just hearing people share their own perspectives, right? I think a lot of people focus too much on having to be right, meaning everybody agrees on what you're saying. There are some things that are unnecessary to say. We can hold those things. But just having your own opinion about life and observing, clicking one level below the status quo. Some people just complain about the stuff at the surface. But the things that inspire me is when the people who click below the surface a few levels and start talking about that baseline fundamental that actually leads to change. And so whenever I see that, I always get inspired. So what does that look like? You're in a country that doesn't have good plumbing system. You're not at a level where you can just go to the department store and buy all the things. You have to create it from scratch. But you create in a way that the people who have access to unlimited capital could never have imagined, and then poof, something new and innovative that even makes these people go and have to study what you did because their lack of constraints will never allow them to be that innovative. They just got too relaxed. I look for these things. So when I look for inspiration, I'm trying to find these things. So when I go to a conference, I'm always talking to a person who, if you ask them, is not important. I can't believe people still say that. I'm not as important as, what? How can this be? Or someone say, I want to be like you one day. And I say, hey, pause. It's okay to learn from what I've done, but imagine if I only try to be a clone of someone else, you would never know my name. And so I take inspiration from people who see that for the first time, and then they become that person. And I get to observe from that person now, and I get to learn from that person. So these days, what inspires me are the things that are hard to find. And they're very simple. It's not who has the most money. It isn't who's the biggest maintainer. I remember going to this one country, I won't mention its name, but the culture there, they just wanted to be a maintainer so bad. That's all they can think of. We just want to maintain something. It doesn't matter, because if we become a maintainer, then the world will respect me. I was like, that is a very sad way to think about open source. This isn't a race. This isn't a leaderboard. This isn't a status symbol. This is a permission to create without the normal rules that govern who gets to build things and who doesn't. So for me, that's the most inspiring thing, because guess what? I don't need permission to inspire other people. They don't need permission to inspire other people. So that's the part that I like. That to me is what freedom is. That is the core of it. And it comes from all kinds of things. It's not just software. I find this in the financial system where there are people who figure out a better way to solve some of those problems. Those people who take the time to smile at another person, just to being patient, that you go to the restaurant and the person smiles at you, and you can smile back. That thing, that's inspiring to me, that people still feel like there's enough room to actually be happy. That's it. So I've learned that I need to go and get inspiration from all the levels. And that's why I think I continuously being inspired myself. So the world is inspiring me all the time. So I can't help but talk this way. I can't help it. Like, I always know that there is a silver lining to all of these things, even the harder problems that we're describing tonight. There's a person somewhere taking notes. I remember that, I'm gonna wrap here. I was doing this KubeCon, and I think it was like the path to serverless. I was showing Amazon Lambda versus Kubernetes. And I thought this was a good talk. I'm in there and people are smiling. People are leaning in. People are closing their laptop, not checking their phone. They're zoomed in. And I think there's probably 15,000 people, 12,000 people in the audience. And for some reason, I'm looking at the one person who decides to get up and leave. I'm like, is the talk that bad? I never thought that this person could be going to the restroom or they got an important call. I was just like, man, this talk must not be going great, but I don't have time to explore it on stage because I have to keep going. And I remember the talk finishes, you know, I think I used some music in that talk. It was fantastic. I was feeling like a rock star. And then I checked Twitter, and this person, I know his name. And he tweeted, I saw something in the keynote that inspired me that I had to leave and go work on it right away. And he created an open source project. I'll leave it to your imagination what the project was. But just knowing that that is possible, a few words can do that, that's inspiration.
Thank you very much to everybody, and thankful. Great question, the last one especially. And thank you, Kelsey, for taking this time and share your experience and your thoughts.
Awesome. Thank you all for hanging out with us too.